Watch closely how this flat, ordinary sheet of paper instantly springs upright into a rigid, three-dimensional geometric structure. That is the objective for today. We are going to transform flat paper into a professional-quality engineered greeting card in under 6 minutes using Pop-Up Card Studio. Before we launch the software, you need 5 specific physical items on your desk: heavy cardstock, a color printer, a precision craft knife, a scoring tool, and your preferred adhesive. Gathering these specific, durable materials first provides the absolute foundation required to make the digital to physical translation possible. Step 1 in the software interface is selecting your starting occasion template and choosing a base color palette. Next, populate the digital canvas with your custom text. The editor supports over 100 languages, so you can tailor the exact message. Then, import a personal photo and anchor it directly over the central focal point of the 3D mechanism. If you plan to involve other people, you need to initiate the group card feature right now. Sending collaboration invites immediately gives your friends and family the necessary time to log in and type their own personalized messages while you continue the physical build. As they submit their text, the software automatically aggregates all those asynchronous inputs seamlessly onto your final layout. Initiating those tools early coordinates multiple schedules, turning a solitary crafting task into a synchronized, multi-person gifting experience. With the digital design locked, generate the high-resolution, print-ready PDF file. This is where the most common point of critical failure occurs in the entire engineering process: automatic printer scaling discrepancies. This animated diagram compares the correct print configuration, strictly set to actual size, against the incorrect fit-to-page default. Using fit-to-page fractionally reduces overall dimensions, which physically misaligns the interlocking connection tabs of the paper schematic. Strict adherence to those exact digital output dimensions is the only mathematical way to guarantee physical structural integrity. Look at your freshly printed cardstock and pay close attention to the schematic legend. You need to make a precise visual distinction between the solid black lines and the dashed lines printed on the template. Take your craft knife and a straight edge and cut strictly along the solid black lines to separate the components. Next, run your scoring tool firmly over the dashed lines to weaken the paper fibers exactly where the precise future folds will go. Flawlessly differentiating between separation paths and folding paths provides the essential bridge between a flat schematic and a functional mechanism. For the physical construction phase, rely on the software's dedicated step-by-step visual folding viewer. The instructions show a critical structural difference. A geometric plane buckling sharply upwards creates a mountain fold, and downwards creates a valley fold. Replicate that exact spatial motion with your physical paper, combining alternating folds into a stable, protruding zigzag structure. Now, apply your adhesive to the designated tabs and press them firmly into place to permanently lock your dynamic pop-up mechanism onto the static base card. Perform a mandatory physical confirmation check. Apply downward pressure to the outer cover and ensure the entire internal mechanism compresses completely flat. Precise adherence to those digital spatial instructions dictates the smooth kinetic function of your final real-world object. It is time for the final kinetic test of the completed engineered greeting card. Open the heavy cardstock and observe the satisfying physical action of the dense paper mechanism springing cleanly open to reveal your sturdy interior structure. A seamless opening motion and a flat, unbulging closure confirms a highly successful structural engineering process. Now that you have mastered these spatial mechanics, you can apply them to inherently more complex template categories, like wedding or intricate holiday designs. Mastering these precise alignment and assembly steps empowers you to consistently produce unique, professional-grade physical objects